Hello, this is Professor Dan Kernler of Elgin Community College. This is another video in my statistics series. This video is all about scatterplots and correlation. All right, let's get to it. All right, we're going to introduce the topics from today's video with SAT scores again, and looking specifically at the Illinois school data. I'll put that link in the description. One of the variables we have in there is the average SAT math score at a particular school. So the averages are going to range. The scores on the SAT math range from 200 to 800, but the averages are not. No school is going to average 200 or average 800. The median of all of these schools is 471.75, so that's the median average SAT math score. Then the first quartile, third quartile, we have the minimum, the maximum. If we put a box around the middle, connect those, we get our box plot. We would expect schools that are good schools we might describe as good schools, to be near the top of that scale because they have a high average SAT math score. Some schools that are close to Elgin Community College that you might be familiar with, something like New Trier, Naperville North, Glenbard West, Neuqua Valley, these are all schools that are kind of known regionally as good schools, and you can see they are in that top quarter of the state. But what we're going to do today is add some nuance to this discussion. What if we added a second variable? So let's take out the box plot and add a horizontal axis about the percent of students in that school who are low income. And then these four schools end up kind of on a downward trend. In fact, if you add the rest of the state, it is a clear downward trend. The more students that are low income in that school, the lower the SAT math average is. Hopefully, it's startling when you see it on the graph, but if you think about it, this should not come as a surprise. Poverty has a lot of challenges, and students in poverty have challenges that students who are not in poverty do not have. And so once you think about it, it seems logical and understandable why the graph would look like this. And what this is here, this is called a scatter plot. And scatter plots allow us to look at relationships between two quantitative variables, bivariate data, two variables. It lets us look for relationships there. So what we have, this graph, we could title this the SAT math average versus the low income density. So it's a Y versus an X. Lest you think I'm picking on Illinois, here's South Carolina, Tennessee, Wisconsin. So very similar graphs, very similar trend. The more students that are in poverty, the lower that college readiness measure is. What we're looking at here is called the correlation. Specifically, we're going to quantify it with something called the linear correlation coefficient. We'll talk more about what that means here. Next, let me talk a little bit about this graph. It's a scatter plot, and it has the predictor variable along the x-axis, and then what we think it will predict, the response variable, along the y-axis. And let's talk about some of these correlations. So suppose we have 5 points right perfectly in a line. That's a perfect linear correlation, a perfect positive linear correlation. That correlation is 1. We use the letter R to represent this statistic, and if they're perfectly in line like that, the correlation is 1. So that's a perfect positive association. If we spread it out a little bit, well, it might be R of 0.9. Spread it out a little bit more, it's moderately positive. Weak positive relationship, maybe about 0.3, no positive relationship, no relationship here at all. And then if we become negative, well, now it can become a weak negative, maybe a strong negative, negative 0.9, and then this very rare, kind of impossible, perfect negative relationship. That's R equals negative 0.1. Now here's an interesting one. Look at this graph. There looks to be a pretty clear relationship, right? It's like a perfect parabola, but R here in this case is actually 0 for us, and I'll talk about why I'm specifying for us, because we are looking at the linear correlation coefficient. In fact, correlation is a very broad topic. I had a whole graduate course on correlation, a 3-credit graduate course. So we're just nibbling on it, and we're going to focus on linear correlation coefficients. So even if there's a strong relationship, but it's kind of a curve, then that's not going to be a linear relationship that we are going to study. All right, let me finish this video by talking about how to do this in StatCrunch. I've got our state education data. Again, I'll put that link in the description. And let's look at this relationship that I was investigating between the percent of students who are low income and the average SAT math score. So the scatter plot is pretty straightforward. It's just a plot. So we go to graph and scroll down to scatter plot. We want to pick the X and the Y. And again, the X is our predictor that we think is going to explain the Y, the response variable. So our predictor is the percent who are low income, and then our response, our Y, is the SAT math average. And like usual, we'll put a nice X-axis label, Y-axis label, and title, and then we get our scatter plot. Finding that correlation is a little more complex because this regression topic is pretty in-depth and we're just nibbling at it. So we want to look to the stat menu, and then there's a regression submenu, and then we want simple linear. That's the only one we're going to do. And after that, it's just like scatter plot. You pick your X, you pick your Y, you hit compute, and now there's a lot here. There's a lot of stuff. We just want to focus on that correlation coefficient. We can see here pretty strong negative, about negative 0.7. So that's the correlation. If we were asked for it, that's what it would be for this particular example. All right, that is it for this video. Thank you so much for watching. If you're interested in seeing more of these, you can subscribe, hit the bell for notifications. I've got a whole series of these coming out. And as always, I want to thank the Elgin Community College Board of Trustees who approved my sabbatical during the spring 2021 semester. And that's what allowed me to record, produce, edit, and post all of these videos. Thank you so much for watching, and I will see you in the next one.